Hello there and welcome to Lower 6th Third Maths A-Level Pure Core 1 Past Paper, June 2016. Here we're working on question 3, which is from the old FP1 syllabus, and it's a series question. Right, okay, so using the formula for the sum of r squared, write down in terms of n only an expression for the sum of 1 up to 3n of r squared. So what we've got here is the formula for the sum of r equals 1 is going to be n over 6, n plus 1, 2n plus 1. So therefore the sum of n equals 1 up to, so this is sum of r squared. From 1 up to 3n of r squared, we just substitute a 3n in where we have n above. So we have an n here, a 3n needs to go there. For the n plus 1, the n needs to be changed into a 3n. And for the 2n plus 1 here, the n needs to change to a 3n. So that's 3 times 2, that'll make a 6n. Okay, great. So the next part is find the sum of r squared from 2n plus 1 all the way up to 3n. So the difficult part here is to sort out this 2n plus 1. Now if you can imagine a long list of numbers being added together, the squares of those long list of numbers being added together, we want to add together from 2n plus 1 squared all the way up to 3n. But the only way we can use our formula is if we start all the way down at 1, so I'll need to go past 2n squared and all the way down to 1 squared. So if I just want this bit here, but I only know a way of calculating the formula for this from 1 upwards, then what I do is I work out the total sum of this from 1 up to 3n squared, and I take away the sum of 1 up to 2n squared. You can see that that will just leave me with this part here, the sum that I'm looking for. So this expression here is going to equal the sum from 1 up to 3n of r squared, take away the sum of 1 up to 2n of r squared. So writing out the formulas for these, I'm going to get 3n over 6, 3n plus 1, 6n plus 1, take away 2n over 6, 2n plus 1, and 4n plus 1. So let's now do the big factorising step. I've just checked we've got common denominators in both of our fractions. If we didn't, I'd need to go and do that as an extra step. So I'll pull out a factor of a sixth. And just looking at both terms here, 2n plus 1, 3n plus 1, that's not common. The only thing in common that we also have is that n multiplied on the top there. So what I need to do then inside the brackets is write down what we have left over, as if you're factorising. 2 bracket 2n plus 1, 4n plus 1. Expand the brackets. So we're going to get 18n squared. 18 times by 3 is 54. So 54n squared. Then we're going to get a 6n, a 9n, a 3n, that will make a 9n. 9 times 3 is 27n. And 1 times 1 is 1, times by the 3, and you get a 3. Take away, we're going to take away all of the components on the right hand side here. So it'd be 2n times 4n is 8n, times another 2, we get 16n squared. Then it's 2n and then another 4n, that makes a 6n, so we'll take away 12n. 1 times 1, whoops, that'll be a plus if it's inside the bracket, and it'll be plus 2 there. So now doing the subtraction, we then get 54 take away 16, and we get 38n squared. 27 take away 12, and we get 15. And 3 take away 2, and we get a 1. Okay, so that's your answer. So to summarise, here we've got A is the value 38, B is the value 15, and C is the value 1. Great, 5 marks for that question.